So today, we will be talking about troubleshooting fundamentals. We will not be diving into specific points of troubleshooting. We will cover some vagaries, but really with a lot of what CompTIA basically asks you to do is they ask you to have the conceptual ideas of how best to troubleshoot things, so that we kind of give you the key skills for doing that. So we could produce a systematical approach for problem definitions and resolutions. So we would talk a lot around those sort of things. So we do hypothetical testing, escalation procedures, and we talk a little about some common computer issues. But next week, we kind of dive a little bit heavier into it, and we go into a bit more of the fat around the troubleshooting items. So we'll cover a couple of areas then. So troubleshooting techniques, hardware. Okay, we know we have got some common parts on our system that will cause some problems. The motherboard, not so much the motherboard causing us big issues. CPU can have problems, display, RAM, storage devices, and we'll talk about some other hardware issues. So we've really got to talk about the troubleshooting methods that we basically produce. So the idea is to get a great value issues and allow us to produce a step-by-step process that we can apply to every single troubleshooting steps that we basically need to make. Now, this doesn't just apply to computer systems, okay? You can literally take these steps and you can push it across the board. If you know, problems with your car, or problems with a window shutting, or problems with your toilet overflowing, we can kind of build around that, and we can use the same steps to do it. This allows us to do a structured approach for the same issues or the same types of issues, and come out with some good solutions, the best solutions possible for that. Okay, it is the best practice. CompTIA will ask you about this best practice and how you should be completing the troubleshooting. So let's have a little look at some of our steps then. So the first step that we do with everything is we gather relevant information. Now, we say relevant, generally this is as much information as we can get hold of, okay? The more is always the way. You will always find, if you go onto a web platform and you're having issues, say, for example, with your browser, they will ask you a lot of other questions. They will ask you which operating system you're running. You know, you're kind of going, well, why do you care about the operating system? It's all about the browser. But they will ask you more questions, because the more information that you gather at the start, the less time that you have to go and talk back to the customer to get other information. So if we get it all at the start, then we can work with that particular areas and we can find the solutions. So we need to gather relevant area. We need to define the problem area. So we need to get some good descriptions from the customer around these. And when we have that, we can then create a hypothesis. And we'll talk about what a hypothesis is in a little bit. And we need to test the hypothesis and have a look at exactly, does it work? Is our assumptions or hypothesis correct? And then we need to verify the full system functionality. So if we tested it, does it work exactly as it should do? Last but not least, we need to document things. Okay, and documentation is important. It is a bane. No, it's not a bane. It's there to basically help improve us in the future. So something that comes up now, we can fix really quickly later on because we've got good documentation. We'll chat about those things. So let's dive into each one with some details now. So gathering relevant information is really, you know, what, when, where, how. Okay, so when does it happen? What does it happen with? Where does it happen? And how does it happen? So we can ask them, you know, does it happen when you're running Microsoft Word? Is it a case that when you're trying to format a particular document to bold, does it then happen then? So narrowing down what is basically happening when it is happening. Then you can use open questions for that, and you can use closed questions. And we'll talk more about questioning when we do a lot of the stuff on the computer support specialist stuff later on in the program. Identify the symptoms. What does it actually do when it fails? And you should always ask, what should it be doing? So what is the customer's expectation at that stage? And compare that against what it actually does. So potentially, if they're saying for a Word document that they're bolding, their expectation is when they hit bold, all the text changes to bold. And they will tell you what's actually happening is when they press bold, well, Word closes down. Okay, so we know there's an issue in there, and that gives us the symptoms. Approach multiple problems one at a time. Okay, a lot of customers will talk to you and they will bring multiple issues around it. Try and narrow it down to a single set of problems. So if they're talking about word crashing, yes, let's focus about word crashing. And they may bring up, oh, sometimes it happens with Excel or with my PowerPoint, it does this and it does that. Well, hold on, separate those, put the Excel and the PowerPoint to one side. For the minute, focus on the Word, fix the Word as a single application and a single issue. And then we can drift onto the others. And it may be that they're all connected, but if you fix one and focus on one, then the chances are it'll help you with some of the others. We know we can review log files and error messages. So do they get error messages? Get a screenshot of them? Do they have any log files they can give you? We know Windows, as well as Linux, as well as the Mac OS, produce log files for particular errors. Okay, so we can look at those and we can ask for those from the user. And it's also important to get the relevant version of the software. Yeah, I mean, if they're saying, for example, our example is that we're crashing Microsoft Word, what version of Word are they running? Are they running the latest MS365? Or have they got a previous version that they've probably got a box product out? So we should find out the version of it. And if it's, say, for example, we mentioned drivers, is it a case that it crashes when they're printing? Well, if it crashes when they're printing, what printer driver do they have? Okay, so the more information, as I said, the better it is at this first stage. Any questions about gathering information? Has anyone got any idea about what other information they might want to gather from people? Please smash something into live chat if you've got any ideas. Or if you don't, I'll skip on to the defining the problem area. See a couple of people typing in there. That's great. Perfect. Look. Matthias basically says was there a recent update to the system? Yes, it's really important. If something has changed on the system, if they tell us that, well, we can go, hold on, if it wasn't happening before, perhaps it was that update. And that then helps us build that hypothesis, doesn't it? If they have an antivirus, yes. Is their antivirus still good? What was the last scan looking like? I would ask which Windows you're using. Which version of Windows? Yes, definitely. Precious, thank you very much for the comment about antivirus. Marty, thank you very much about the one about Windows. Which Windows are they using? Yes, so the operating system, the version of the operating system, it's all relevant stuff. Good stuff. Good to see you guys thinking about it already. So then we talk about defining the problem area. So we're talking about determining the recent environmental or infrastructure changes, which refers us back to what Precious has basically said, and narrowing the scope of the problem. If someone says, my Word is crashing all the time, well, it's not crashing all the time, is it? It's crashing some of the time, and we've got to narrow it down to what specifically do they do when it crashes. A lot of people will come to you with a very vague area of things crashing. My computer's rubbish, it keeps falling over. When does it fall over? Is it when you start a particular application? Or is it when you do a particular print job? Or is it during an update for the antivirus system? Okay, so we've got to narrow it down to what they are doing when it basically crashes. And then what we do with this information that we've now got a good idea of what happens, what should be happening, what they say is happening, and what they're doing when it happens. So once we've got all this information, we can then look at formulating what we term as a hypothesis. And we can formulate our hypothesis with a bit of research. We are not stuck on our own, on our computer. We know the internet's out there. And we know when we are basically working for a company, we will have knowledge base articles. So we will have a knowledge base that we have access to that contains common known problems that companies have. Okay, and we can do a bit of research. Can we load up, say, for example, if they're saying they're having problems with Windows 11, with Microsoft Word off of MS365, and it happens when they're bolding their text? Well, hold on, I can load an operating system with Windows 11 on. I can load the same version of the application on my system and I can test it. So do some research. Does it happen on my system? Does it happen on everyone's system? Okay, so we can do a bit of research into things to see where it falls over and see if we can reproduce it. The gold dust is a reproducible problem, because if you've got something you can go at home, well, at your desk or wherever it is you happen to be, you can go, if I do X, Y, and Z, oh, the same thing happens to me. If that happens, then you've got something you can reproduce. If you can reproduce it, you can look at fixing it. So we can make changes to our system to try and alleviate the problem. And when we find that, well, hold on, that's going a bit further. I'm jumping a couple of steps up further, but yes, that's really what we're looking at. Last point on this particular slide is questioning. Okay, one of the checks needed in this step is really questioning the obvious. Do they really mean they're bolding text, or are they doing something else? So let's have a little look at some of those. Consider looking at multiple approaches to this. Okay, so consider looking at different angles. We may talk about things such as workarounds, okay, but once we've created a hypothesis, we are then moving on to testing our hypothesis. So confirm that we can make it to fail. If it is from an update that was mentioned by Matthias, is it possible we can roll back that update? Is that an option for that particular user? And we can test that by rolling back the update. Does it still happen now? If the answer is no, well, we can look at the update potentially being an issue. What's wrong with the update? We can chat to the manufacturer and have conversations about why it's crashing. When you do make changes to a system, it's important that if you are making changes to test your hypothesis, don't do a load of them together. Because if you make 4 or 5 different changes, you kind of go, well, it's crashing now. Let me change the version. Let me roll it back one version. Let me load a different version of Word. Let me not bold it. Let me try and italic it. Let me use a different document. Okay, if I'm making 3 or 4 different changes and it works, I can go, oh, that's great, it works. Which one of those has fixed it? The answer is we don't know. Okay, so do one change, test, one change, test, one change, test, till you hit the one that basically fixes it. Then you can revert everything back and just do that one change, test. And if you get that, you know where the problem is caused, you know how to resolve that issue. And don't feel shy about rejecting your hypothesis. So if you get to a stage where you're kind of trying lots of different things and you're thinking it is this, it doesn't actually make any changes, then no, there's no point flogging a dead horse, as my nan would say. You can go to it and can simply go, okay, we don't think it's that anymore because we tested it as far as we can. Possibly is it something else? Let's think of a new hypothesis to test against it and look at something different. Some experienced technicians might usually skip the first couple of steps if their method and common issues, if they know about common issues and their experience will lead them in particular directions. And you indeed will get that. So as you start working in these particular positions, you'll get more and more skills around working with these issues, and you'll understand what's going on with the applications and the systems, and you'll get a good idea as to exactly where you should be looking. Anyone got any questions about testing their hypothesis? Can anyone think of a good platform I could attempt to test hypotheses on? Obviously, if I don't have the relevant operating system directly on my machine, I'm not running it. So I know where I could potentially run up a different operating system to test it. See a couple of you typing in there. Mardy, your excuse for using an acronym because it is such a popular one, VM. So virtual machines, yes. We know we can use virtual machines, okay, to test hypothesis. Yeah. So if this customer is running a particular version of Linux, well, we can load that Linux onto a VM and we can test things on that virtual machine. But of course, we've got to remember with our VM, we may not have the same network connections if it's a network issue they're having. So we've got to go kind of careful in terms of trying to replicate exactly what the customer has. Certainly with a VM, it can be good fun, definitely. Great place to test things. Thank you very much for that comment. we have step 5, escalate the issue. Okay, every company will have an escalation procedure. Lots of companies, if they're sizable companies, they will have what's known as first line technicians. These are the people that take the frontline calls. And to be honest with you, they're going to be able to answer about 90% of the questions that come into that company desk. When they can't fix it, they go to a second line tech support, which is known as an escalation. Their second line, some have third line, some have fourth line. They tend only to top out at 3, to be honest with you. Okay, so the idea of those frontline technicians, the first line people that come in, is pretty much a triage system. They check all the things that they know already. They have a little look and they're allowed a certain amount of time to play with things, to load a VM, to test it, to have a little play and see what they can work out and see if they can fix it themselves. But then if they don't have any further time, there's no harm in those guys escalating it. That's the way the process is supposed to work. First line technicians pick up about 90% of the issues, pop the more tricky ones off to the second line technicians that have more experience, and we'll spend a bit more time basically trying to resolve those issues. Do not feel shy about escalating it, because you've got to focus on what you're doing here. We're focusing on the customer. We want the quickest solution for the customer. If you're going to spend 5 to 6 hours researching it, or you're going to park it while you have to deal with all the other questions you've got, that customer is getting delayed and delayed and delayed. They have escalation procedures for a reason. If you escalate it, that person will be able to dedicate the time to it and provide a solution for that customer in a faster way than you probably could do if you had to deal with all the other things you need to juggle. That's why we have escalations. Don't feel shy about that. Okay, and then we can verify the full system functionality. So once you've reproduced it and you've created a fix, now you've basically just got to check that you haven't broken anything else. Because remember, it's not just one thing you're changing. If you change one thing to fix it, that's fantastic. But does that thing that you changed have an effect on anything else? Classic example is if you're using something like a particular browser, Google Chrome browser, and you find the solution is actually to downgrade that Google browser to a previous version. That's great, that's fantastic. But what about the security issues I've just created by downgrading Google? That could open up a security vulnerability. It could be that the latest account software needs the update for the Google browser and won't work without it. So you have to make sure that all the rest of the functionality for that user is going to work perfectly okay. Has anyone had any experience where they've kind of upgraded or changed or altered something and it's kind of broken something else? Either on your computer system, fine, or even at home. Just type something into live chat if you have. We had a my dad used to work. My dad used to work a lot with the Scouts, with the Boy Scouts, and we had a minibus called Belinda, or we loved Belinda. But we had a very keen, enthusiastic guy that used to come round, and he was a bit of a mechanic, and he couldn't fit enough weight on Belinda because of the suspension that was on there. So he wasn't allowed to, he couldn't put all the canoes he needed in there, all the canoe gear, all the rock climbing stuff, and then take Belinda out because the old suspension just wasn't good enough. So we upgraded the suspension, massively upgraded the suspension. Belinda was then about, word of a lie, Belinda was about a foot taller than she was previously. Lovely girl she was, lovely bus. But of course, when you took her out to drive with no weight in it, she rolled something horrible. So again, we upgraded to fix one problem, but we caused another problem. So you want to make sure that's what you're doing essentially with a full system functionality test, that the changes you make do not impact anything else on the system. Any questions about verification of the system functionality? Give you a couple of seconds if you want to type something in live chat. Good stuff. And then the final step that we have is essentially document those findings. Okay, we rely on documentation because it's something we can refer back to. If we're making a change to a customer system, we should know when that change was done, who it was done by, and what exactly that change was. So that if the customer comes back to us 2 to 3 months' time, we can basically say, look, these were the changes we made with your agreement. We're not sure why it's broken now, why you claim something is falling over now. So we've got essentially a record of what basically happens. It also allows us to do what's known as root cause analysis, which is where if we get multiple incidents on a particular problem, so if you get multiple people that cannot access their email, yeah, we fix it once. What happens when the next person phones up with the same issue? If we've got it documented, we've got a root cause analysis, and then we can simply refer back to the original document that fixes that particular issue for that customer or any other customer that phones up with the same thing. So it's important to basically keep those so that we can keep track and we can improve. And that way, the next time someone phones up with that, we look at our knowledge base that has all these articles. We go, oh, that's the one that fixes it. Here's my solution. We can skip out all that previous stuff we've done, and that saves us time. And what is time if it is not money? So that's what it's all about. We can also do things such as incident postmortems. So when we document it, we can look at what's happened. Say, for example, the good example that we had with some system being updated. So was there an update? So when we do a system postmortem that says that update causes this particular problem, do we then prevent that update from happening across the rest of the computer systems, across the rest of the company, that then prevents everyone phoning up with the same issue? That allows us to do a postmortem and try and fix something. And it also helps us with some reports, so we can see how long it takes us to close particular issues, how well we're doing against particular KPIs, key performance indexes. But really, the whole goal of basically doing the documentation is so that we do not have to repeat the same steps to get the same issue to a solution. Has anyone done any document writing for technical support or any troubleshooting methods? Great show of hands, and a little description would be good if you have. See a couple of you typing, which is great. Marty's basically asking this question, how do you document? I've never done it. Perhaps I should have a little chat about documentation then. Yes, we can spend a couple of seconds doing that. Just waiting for Ernest to finish typing and see what they've got. Let's crash into documentation. When you work for a company, I've mentioned we go into a lot of details in this further on down some of the lectures, so I'll kind of cover it gently here. Okay, Ernest basically says he worked in a call center at AT&T, and it's mandatory to document every CX interaction in our CRM. Wow, there's a lot of acronyms in there, but we'll cover those. CX is customer experience, and CRM is customer relationship management software. So what you basically have, this is for all of you. You might as well learn about this now. We'll do a quick piece. So what you have is a CRM that contains details about problems and customers. Okay, and that CRM, you have what's known as a knowledge base, and the knowledge base will have a lot of articles that are written, and we'll talk about how you write those in a minute, for those particular problems that we know about. So any issue we know about goes into our knowledge base. We can pick that, come to the solution really quickly. Those knowledge bases are created by people to essentially get those issues. So if I was to get an issue, I can write in that knowledge base all the details that I have in terms of what operating system it happens on, what browser it happens on if it was a browser issue, what the steps were I did to reproduce it, how I fixed it. So I can write those down. Now, we don't have to think about how that looks because they're normally templated. So normally in your CRM or your knowledge base, They are templated for you. So when you are creating a knowledge-based article, you will have little points in there that will ask you, what operating system was it? You fill that out. So we don't have to do the thinking about, oh, what do I write? What do I need to put in? That's all laid out to us in a template. Is that clear for everyone in terms of how that works? And you can create it fairly freeform, and a lot of companies will do this differently. Some will be fairly freeform and open. Some will be very regulated in that you will have, you know, as I say, a templated operating system, software that it was on, what actually happened, you know, in terms of the error that they were getting and the solution. And they'll be date and timed so that we can kind of review them every 6 to 12 months. Does that answer that question for you, Marty? Perfect. Is that all clear for everyone else, or does anyone else need me to go over anything else about the documentation? Let's see Paul type in. Ronald? Perfect. Okay, great stuff. Well, let's have a little conversation about a scenario-based practice. Here we go. It's a good example. And we'll go through each of those individual steps here. And we're going to use live chat to basically manage some of this. So, a scenario-based practice. Oh, Chris, we are seeing your live chat and lots of other people are typing stuff. We'll get Ragib just to have a little conversation with you to see about picking things up. Make sure it's all good. So we're going to do a scenario-based practice. So you've recently transitioned into a role as an IT support analyst. Congratulations, pat on the back for that, in a mid-sized company. Multiple employees from the marketing and sales department have reported issues with their computers. Specifically, slow performance. Okay, users complain about the delay when running marketing analytical software and accessing customer relationship management, so our CRM tool. You need to investigate these to address the reported performance issues, ensuring that you utilize all the steps outlined in the method. Okay, so first of all, what questions are we going to ask? You feel free just to smash some questions into live chat. If I'm on the phone to you, chatting to you, going, it's running horribly slow, not working. What questions are you going to ask me? Feel free to just smash loads of stuff into live chat here. Paul Bird says, when did the problem start? Yes, when it starts, and when it stops is a great thing to ask. When does it happen? Chris, we hope you're back with us and you can see people typing through. Oh, here we go. We got a couple. Precious says, when last was the software updated? Yes. When was it updated? What version is it on? There's a good question as well in there. Well done. Paul basically says, well, I'm going to lose half of these at the top of the screen. What were you doing just before the problem started? Yes, because it's important to understand what leads up to the problem. Have they? Oh, I like that, Majel. Oh, yeah, it says, did they restart their PC? Turn it off and on again. We know that's one of the things we quite often do in IT. Cablan says, how many users are experiencing the slow performance? Is it isolated to specific individuals, teams, or departments? Yes, very good question, Cablan. Pat yourself on the back. Is it everyone or is it just one person? It's one person. We can target that particular person straight away, that their log on, their hardware, their network connection, rather than looking at everyone's network connection. Good question there, Cablan. Riley says, have you recently installed something new? Yes. Has there been a new installation? Are you using lots of software applications at the same time? What else is running? Very fair. Because that could, again, burn up their memory, couldn't it? And use their processing power. If they're running multiple browsers up there, multiple applications running, changing enough, their CRM runs slow. Not surprised, is it? Good to see you all thinking there. If I miss out anyone's comments, please don't feel left out here. I'm reading as quick as I can. Matthias. Okay, then. How long is the uptime on the system? How long has our system been up? Does it need a reboot? Is our server running slow? They wouldn't probably know about the uptime. They know how long their system's running, but yes, really good. Peter says, if such a situation has happened on site before, is it common? How often does it happen? All these are really good questions you're coming out with. Cablan again, very similar to the Peter one. When did the slowdown first start? Was it sudden or gradual? Is it something they felt over months, or is it something that's just happened today? Ronald, I like that one. Yes, thank you very much. Ronald says, did you click the ad saying you've won a brand new iPhone? Okay, we know ads and things like that on emails are phishing attacks, and we talk about that in the security stuff. So yes, did they just install some malware onto your system? Paul Bird says, any other system affected, or is it just the CRM? Good. I've seen loads of comments here. Lots of you doing some great thinking. This is all about information gathering. We're doing information gathering, information gathering. Luca says, I like the idea. I like the reference to Colombo to see if some of the workers made this happen to avoid actually doing some work. Marty basically says downloading things might also cause problems. Yes, so this is good. So now we're gathering all the information. We've got some lots of information. How can we look at identifying the problem? If we say, for example, I'm going to throw in some stuff in here. It's only caused by one particular user. They're just a bit louder than all the others. So the one user is having the issue with the CRM. They haven't downloaded any software or clicked on an ad to say they're winning a new iPhone. And they haven't got any other systems open. So what sort of theory or problem do we think we can have a look at there? Fire the pullback. You can't just fire everyone. You're not Alan Sugar. So it's only one user. They haven't got anything else open, and they haven't added or downloaded anything malicious on their system. So what theory could we potentially come up with there? Don't have to get it right. We just need to bring a theory in. Restart, reinstall. Yeah, could be faulty installation. And is that's something, Maljet, that we can test ourselves, isn't it? We could quickly do it. If we have spare boxes, spare PCs, we could simply swap the whole PC out, couldn't we? Check the available drive space. So you think it could be a RAM issue or a disk space issue? So these are good theories that are coming in. Has that computer got enough RAM? Another PC as backup can be used for a try? Yes. Mijouch basically suggesting that that's fantastic. What happens if we put that user onto another PC that is working perfectly okay and get them to log on with their own account? Does that run slowly? Last update that could cause the problem with functionality. We kind of said they didn't do any updates, but yes, it's a great idea. Okay, so let's have a look at this and let's kind of round things off. Let's say, for example, that he's the only one. We discover that he's the only one with 4 gigs of RAM on his machine. Everyone else has 16. So now we've established that potentially we're looking at the problem. Our hypothesis now is he has got not enough memory on his machine. So let's establish a plan of action. What is our plan of action on this one then? Switch it with another PC. Upgrade the RAM. Upgrade the RAM from Kablan and Mardi. Yeah. Rajouch basically says, or upgrade. Yeah. Delete some files. The files won't actually affect the RAM that they've got on the machine. Remember, RAM is the memory. Your files are normally written to the hard disk drive. Upgrade the RAM or replace the PC. Yeah, so we've got a plan of action now, haven't we? So we've got a plan of action. They don't have enough memory. Our plan of action is to either swap the machine out or to replace the RAM. There you go. So we've done our couple of steps. Let's say we upgrade his RAM, so we boost him to 16 gigs. Now, how are we going to test that that theory is working? Very simple questions that we ask at the end. Towards the end, the stuff is really simple in terms of just following through. Optimizing the program. So once we've upgraded to 16 gigs of RAM, how are we going to test that everything's okay? Marty basically hits the nail on the head. Yes, we simply test it again. So we do the same task, test the problem is still persistent. Do the same task on a different machine. Yeah, it's pretty good, isn't it? We kind of swap things around, isn't it? Run the software after upgrade. Yes, so we're basically having a look there, aren't we? Okay, so let's have a little look. So we closed it off. Everything works perfectly okay. The user can access all the other systems and everything's fine. They can access the CRM. We've established now that it's correct that we need 16 gigs of RAM to access our CRM properly. How does our documentation look? So if we produce a document now, we've got a document that basically our documentation says, this is the issue, accessing CRM slow on a machine with 4 gigs of RAM. Next step down below on that knowledge base article literally says, solution, upgrade to 16 gigs, close. So next time someone phones up now and simply says, it's really slow accessing my CRM, one of the first questions that gets asked is, how much memory have you got? If they say 4 gigs, bang, well, straight away we know we're upgrading to 16, problem solved, happy customer, really quick solution. That's what we're after. That's why we do the documentation. Anyone got any questions about that scenario-based practice? Thank you very much. We had some great ideas in there. Thumbs up if you're all good with the scenario base. Good. Marty, Ronald, Paul, Zachariah, Luca, Binta, Precious, lovely. Okay, that's good. Peter. Good. So that's really what we're on about, isn't it? So it's scenario-based testing. We follow those steps and we can come to a solution. So now we kind of taught you a few things. Let's have a look at some specific stuff. Troubleshooting techniques for storage drives and RAID arrays. Let's have a show of hands. Who's had a problem with their disk drive before? Cablan has. Maximilian? I'll put my hand up. I definitely have. And of course, because of my job and what I've done, I've known lots of people that basically have had issues with their disk drives. Recovering a disk drive is very, very entertaining. Certainly if it goes pop. Oh, Paul Bird, once just that it was because I dropped my laptop and it was a hard disk drive. HDD, I think you meant to put in there, Paul, but yes, definitely. Mine was so slow, I had to upgrade to an SSD. Yes, definitely. Corrupt disk drives. Oh, corruption's horrible. It's nasty when you lose things, isn't it? Okay, so let's have a quick chat. We know a hard disk drive, okay, stores data on spinning platters. Okay, it's physical, it's mechanical. Okay, it provides great storage space, lots of space. They are slower than SSDs, but they are cheaper than SSDs. As a speed comparison between the two, well, let's talk about SSDs. SSDs are flash memory, okay? Used to store data, offering fast access, super fast access, improved performance, nothing spinning. If you drop a machine with an SSD on, well, the SSD doesn't really care unless you actually physically damage the SSD because there's nothing spinning around. We'll have a little look at why it's so important on a hard disk drive. So speed comparisons, a hard disk drive normally will run about 150 megabytes per second. So that's reading and writing. An SSD is around 500 megabytes per second. Wow, so you can see why SSDs are so popular in laptops. They are so much quicker and they're popular in servers, quicker but more expensive. So if you can afford the memory, afford the money rather, then you end up with SSDs. So as a recap, I think we kind of spoke about this when we did the inside computers and what the hardware actually is. Okay, your hard disk drive essentially is run by a set of magnets. You've got an actuator, you've got a read head, you've got a drive spindle, and you've got lots of little plattons. The problem when you physically drop one of these is that little read head that we've got there simply goes like that, and it bounces up and down on the disk. If it's bouncing up and down on the disk, it's destroying data. Okay, so that's the problem. Most disk drives actually move to what's known as a park zone when you power it off. So it will swing itself 100% one way. So it's not over data or anything it will damage. But you can still damage the disk drive itself. Okay, so the problems that can get caused on these things, you get file corruptions, you get bad sectors. So bad disk sector just reduces the amount of space you can have on a hard disk drive. If you hear a disk drive with a clicking noise, please look at getting it changed or making sure you've got a good backup. The clicking noise is normally a sign that the disk drive is going out, and it's not a tick, tick, tick. Sometimes it's just a little grind. You hear grr, 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 grr. Wow, that's a great impression that was. I think I should get some more audio to do that next time. But yes, you will get something like that. If you hear it churning, you shouldn't be. Okay, that probably suggests you're getting an imminent failure on the disk drive. Back it up, replace it, do what you can to get it changed. Sometimes you get things that are just out of space. Okay, so hard disk drives will run out of space and that will cause you problems. Things such as a slow rotation speed. So these things they are mechanical, so they can have issues. So you can get slow rotation speed that will then cause slow data reading, and that gives you problems. Now, who's put your hand up? Let's have a quick show of hands. Who's heard of SMART? Self-monitoring analysis and reporting technology. I don't mean there was a, I'm taking you back years. There was actually a spy agency, a program called SMART. Oh God, I'm showing my age there. You'll have to look it up on the internet, okay? It's quite funny. It's sort of a comedy CI5 sort of thing. So Cablan's heard of SMART. We will chat about SMART in the future in a bit more detail, but just to know that it is there to help you. And of course, last but not least, in terms of common issues, accidentally deleting files. Oh, people do this quite a lot, unfortunately. So it is possible they will accidentally delete files, and that causes all sorts of tears. Can we recover from accidental deleted files? There's a question for you. Let's have a show of hands. Let's have a thumbs up. Is there a thumbs down icon we can get to? Thumbs up if you think you can recover from it, or just a simple no if you think you cannot recover from a deleted file. And we're talking without using a backup or anything like that. Chris Ronell. Paul Bird, sure you can, but it's not straightforward. Right, yeah, okay, so we're going to get a general consensus there that yes, you can. Yes, you can. It's not easy. It's quite interesting. I'm going to bore you to tears now just by telling you some stuff about this. When you actually write a file, okay, it's a string of ones and zeros. When a file gets deleted, what happens is actually that there's a header at the start of each file that says I'm starting now and I'm ending here. So start here, end here. That's where my data is. When you delete a file, what happens is the operating system, it's lazy. It doesn't want to rewrite all that data that you put in. What it does is it comes along and it simply changes that and wipes that piece out. So now you've got no reference in terms of when that file starts or ends. So no one can read it. That's a deleted file. What a lot of the recovery software does is it hunts for these deleted areas and attempts to recover that particular piece. If we replace that piece, well, the file's still there in its data, so it'll be able to recover it. I've watched years ago, I watched a guy on a disk do this manually. My God, he was bright. It was shocking what he was doing, but he literally went in with a disk editor, found where it was, and then manually I was just looking at him going, oh my God. Okay, so it can be done. Software does it. Yes, you can recover from it. Okay, so here's one of our big nemesis on spinning disk drives. You see all the bits in the background. Yes, grinding noises or clicking noises are very important that you replace the systems. Any questions about disk drives? Okay, so great. We'll move on to boot device is not found. Okay, we know within our BIOS and our UEFI, that tells us which boot devices we're looking at. If the boot device isn't available, or it's trying to boot off a device that has no operating system, you will get our boot device not found. I think I probably mentioned this every single lecture, not a surprise. Some people in the old days had floppy disk drives, and we used to get so many people who accidentally leave a floppy disk drive with some data on in the disk drive. They turn the machine off, go home, have a lovely glass of wine, come back in the morning, turn the machine on, and they'd get an error message like this: boot device not found. That's because the BIOS in UEFI, by default, will attempt to boot off of what used to be called drive A to the floppy disk drive, then drive B, then drive C. Natural, it's in that particular order, isn't it? Okay, if that disk drive was put into drive A with data on, it has no boot reference. So it has no operating system. So the system goes, I can't boot off this. And we used to take lots of calls, and the first thing we used to say was, is there a disk in drive A? Oh, and they'd apologize, they'd click it out, and everything would be fine. It's as simple as that. So check the UEFI, check which disk it's trying to boot off of. Check whether or not they've actually plugged one of these things in the side of the machine when they're booting. Because UEFI and BIOS will also potentially try to boot off of one of those. So those are the general causes for those particular issues. And I won't tell you that years ago, people used to use CD drives as cup holders. And it's quite interesting. What's this little cup holder doing on my machine now? Oh, that's great. It's not a cup holder. Never mind, Dave. Those are the days, eh? Now you won't get a laptop or a machine with a CD drive, will you? So that was boot. So other particular things that could happen are, okay, we've talked about the boot order. Yes. Your CMOS battery. Who wants to remind me in the live chat what my CMOS battery is? Let's see who's still there and still remembering those stuff. The little battery on the motherboard, I believe. Well done. Okay, there's a bag of sweets coming your direction. Paul Bird for the clock. It's not just for the clock. It holds the BIOS information or UEFI information. It gives power to that particular chip so it doesn't forget things. Thank you, Paul. That was beautiful. Okay, so yeah, so if the CMOS battery goes, it forgets the boot order that you might have set. We know it can also happen with things like auto detection functions. Viruses can cause problems. Okay, if a virus destroys your operating system, prevents the booting, yes, you're going to have fun there. Okay, so generally when it says device not found, these are the things we are looking at. Okay, solutions, yes, we can restore this from a recent backup. We talked about Apple Macintosh booting into a recovery mode, didn't we? Windows will also do that, and indeed some of the Linux OSs will allow you to do that as well. So you can restore from recent backups. Or you can simply load an OS from a live USB key. So you can basically plug a USB key in, reboot the system, and off you go. There are other reasons as well. Potentially, you might have one of the cables loose. So if your SATA cable or IDE cable has basically come loose, or your power has gone to the disk drives, remember there was 2 cables plugging into each disk drive. If that's the case, yes, then your disk drive will not be available. So we might have to take the lid off and have a little hunt around inside. So we can get data loss and corruption for a variety of reasons. We talked about mechanical failures, yes, dropped, cables lost, that sort of thing. Software issues, power issues. I'm not worried so much about the power issues one at the moment, but software issues, yes. We know malware, very, very much front of everyone's mind at the moment, because a lot of the major shops have basically been hit by malware, which has obviously caused software issues. Keep your antivirus up to date. Do not click on anything at the moment. It's very scary moments out there for a lot of shop owners. The data loss comes in 2 particular formats. We like to break it into 2. Small data loss, where it's the limited amount of data. Unintentional deletion. Yes, I've accidentally deleted this. Small bits of corruptions, compromise. Yes, we can back these up and we can restore things, can't we? So we can always restore these things. Or there's large data losses. Okay, that's substantial, widespread stuff. The large data loss is more than likely caused by malware, basically encrypting all the data on the disk drive, or a disk drive simply going up in smoke. Okay, these systems should have been backed up and should be looked after. So there's a couple of things we can do. So mitigating data loss, so precautions and solutions, so preventative actions. So if you're hearing that little clicking on your hard disk drive, don't write new data to that disk drive because it's going to cause it more problems. We can seek professional assistance. Hold on, we are the professionals. We're looking for a job in IT. So we speak ourselves and we look at in terms of how can we restore the loss? How can we keep the backups good? There are diagnostics tools out there which will check your disk drive to help you identify isolated damaged sectors on disk drives. And of course, we can use real-time backups, snapshots and things like that to keep our backups regular and keep things safeguarded. And we do have a section later on in the lectures that basically covers backups and how we manage those and how corporates basically manage those as well. We know now our backups basically go as cloud storage options. But if all comes to the end, we know we can lean on some data recovery software. It is going to cost money to recover anything. So backup is your first line of defense. So all the operating systems have a disk maintenance tool. CompTIA will ask you a little bit about this, not in any massive detail. Okay, so Windows basically has several check disk, SFS, Windows disk error checking, Windows optimization, and defragging drives. Okay, let's have a look at defrag. It's always on the list. Can I run defrag on an SSD? Let's have a thumbs up or a yes or a no would be fantastic. Oh, I love this. Can we run defrag on an SSD? Gonna see if I get any different answers. As a clue, I'm looking yet to send anyone some sweets on this question. No, Maximilian, thank you. You get the sweets, Maximilian. Paul Zachariah Mardi. Okay, not to worry. Not recommended. Don't ever run it on SSD. What defrag actually does, when we write to a disk drive on a spinning disk drive, we are writing in sectors. So we write a bit in one location, write a bit in another location, write a bit in another location, depending where it is. So over time, our disk becomes what is known as fragmented because we've written here, we've written here, we've written here. So the next one goes, oh, I've got to write there. But when I'm trying to read the files aren't in order. Okay, so I might have to read from here on the disk drive, here on the disk drive, here on the disk drive. Hold on, that's a lot of movement for my disk head to do. So it's a lot quicker if I read from here and here and here and here. So what defrag does is it takes them all, organizes them all, and puts them all in the right order. So I want to read my large data file. It can be read in one big go, rather than having to move the disk head all over the place. That's what defragging does. SSDs, well, SSDs don't have fragmentation because they are a piece of silicon. So there's no movement to read from different locations. There's no delay if they're fragmented, who cares? So you do not defrag an SSD. Was that clear for everyone? Fantastic, good. Okay, Linux tools. You won't get asked so much about these are on the CompTIA, but we do cover them. So IO stat reports the CPU and disk IO statistics. That tells you if it's performing properly. Top is a real-time system monitor tool, basically displays the resources. I won't go through all of these. Fdisk is in there as well, which allows you to format disk drives. Mac resources. A lot of these are basically done from the GUI anyway. So Mac stuff has IO stat. And again, wow, the same command on a Mac as we have on our Linux system. Yes, not a surprise, as we spoke about that last week, didn't we? So we do have some disk maintenance tools that we can use. Here's an example of a Windows command, which is a check disk. And you can see it spews out a lot of information here. So check disk /s perimeter not specified. That's on the left-hand side one. So what that does is it goes around, looks at all the bits on the disk and says, is this a readable, writable section? Is this fragmented? Does it work? Are there any bad sectors? So you can see we've got 0 bad files recorded. Okay, and we've got a certain amount of bad sectors. Can it recover those? Yes, the /f command allows us to recover those. Now, don't be scared of the fact that we potentially have some bad sectors. This is a good disk drive, 0K in bad sectors. Sometimes you will get bad sectors, and the disk will run perfectly okay with bad sectors. It's pretty much expected. Don't think you need 100% perfection. The /f, what the /f does is it makes sure it marks those. So it says these are bad sectors. Do not write any data to here because they failed before. And that means you do not have any read-write errors. Any questions about the check disk command? IO stat here, you see basically gives you the stats for it, and that's on the Mac. And we have some Mac utilities that basically can be used in there. So we have disk utilities on the Apple that tells us the capacity, the availability, and a snapshot that we can create. Now we're going to quickly cover Smart before we go for a break. And then you can have a 10-minute break basically to look at a coffee, pancake, or an apple. Smart is a self-monitoring analyst and reporting technology. It's generally used on servers. Okay, it's very important use on servers. What it does is it's constantly monitoring your disk drive. So it looks at your disk drive and says, is it reading and writing at enough speed? Okay, is that speed what we expect it to be? Is the disk, if it's a spinning disk, is the disk spinning as it should do? Is it spinning fast enough? And what it does is it keeps an eye on the disk. So what Smart will do is it will recognize disks that are falling over. So if your disk drive begins to fall over, Smart will literally say there's something going on. So this is what you get. You get error messages from Smart, and this is given basically to your operating system anyway. Here's a typical error, read rate or read error rate, critical. So that basically says the data rate that we're reading and writing to the disk drive failed. That's a critical error at that stage. Your Smart system is going to raise a flag and say, hey buddy, replace this disk, something's going wrong. There's a throughput performance error. You don't have to know these off by heart. These are just examples of Smart. So the throughput performance error is ID X02. Okay, that basically means you're getting a decrease in the read-write speed. It's not a critical error because it's not totally failing. You've got a spin-up time failure. You've got a stop-start count. Okay, and you've got a reallocated sector count. So all these are going to cause particular errors. There's loads of them, but really your Smart array is just monitoring your disk going, is it still okay? Is it still behaving itself? Okay, and on the server, it's quite important to think about those things. Any questions about Smart then before we pop off for a quick 10-minute boogie with some great tunes? Marcos, sorry, the answer. Marcos asked a question there. The DF disk on Linux and Mac is the defrag drive. Yes. Don't do it. If you're running a Mac, don't do it. 99% of Macs have basically got SSD, so don't defrag it. I'm very surprised we still use defrag in any of these things. Go on, see Marcos. Don't defrag your Mac, Marcos. Well, you can check you've got an SSD because you can check the hardware you've got on there. Okay, I can see Marcos still typing. You've got both discs. Okay, so make sure you are defragging the right one, please. Please don't break your Mac, Marcos. Okay, so let's have a 10-minute break, comfort break. A little bit of a boogie music. And we will see you in 10 minutes. Let's have a quick thumbs up for anyone who's a country and western fan. Marcos is, yeah, definitely in there. Prince, Fantan, Ronell, Peter. Oh, beautiful stuff. Some great music played there. Right. Without further ado, then, who can see the RAID failures? Oh, thank you, Precious. I hope that's for the RAID failures. Khalif, Paul, Zachariah, sorry. Great stuff. Okay, so let's have a look. So RAID failures. We kind of talked about a variety of things. Smart is important because it talks to us about our disk drive health and safety. Not safety, disk drive health and status is what I meant to say. So RAID failures. We know RAID is there to protect us. Okay. You can have failures with RAID because you could get loose power cables, loose data cables. You can have physical disk failures in the arrays. Yes, it does happen. We can have RAID getting disabled in the BIOS can cause us problems. And we can also have multiple RAID configurations or RAID controllers that are configured that interfere with each other, and that causes some problems. But we've spoken about RAID, so let's have a quick chat. We've done this before, so we'll just is sort of a bit of a recap, isn't it? So RAID 0 is simple disk striping. So it doesn't provide anything against failures. If one of those disks goes, yeah, mate, unfortunately, you are losing an awful lot of data. Okay, the information is split along the RAID itself. So you get no protection there. RAID 1 essentially is mirroring. Yes, you do get some protection here. If one of these disk drive fails, the data is written equally to both. You can see you've got A1 on both disks, A2 on both disks, A3 on both disks, etc. That means we can lose one of those disks and the system will carry on going and writing data. Bit of a recap there. So RAID 5, this is our disk stripe. So remember, we're writing across all the disks. And with one of them or 1 basically getting used as a parity. So you can see we write A1, A2, A3, and then A parity gets written to a disk. B1, B2, B parity, and B4 gets written to a disk. Okay, so this basically means that all the time we can lose one of those disks, and with the parity being written, we can then reconstruct that data. Sure, so we can now lose one disk, which is great. So that's the benefit of RAID 5. RAID 6 has double parity, so we're writing the parity twice. Yeah, we can lose 2 disks, and we're still going to be great. Well, I think we covered that when we covered RAID when we basically did it. But that's just a little recap to let you know that the RAID 5 is probably the most common that's used because it's cheaper than the RAID 6 because we haven't got the extra disk, the extra parity. Any questions about RAID? I know we fly through that, but we kind of covered it in previous lectures. Cool stuff. So all our systems that count with RAID basically have a RAID controller. This is the device that allows us to use multiple disk drives. Okay, so it manages either solid state drives or hard disk drives. It coordinates with computer storage and basically helps build the arrays. So we can get this as a physical card. Some systems it's built in on some of the motherboards on servers. The server that I demonstrated to you the other day has a RAID controller card. One of these basically mounted on its daughter board. So that's the one that goes horizontally on the server. It is possible that these do fail. They are electronic devices. So it's possible that the RAID controller will fail. You will lose the entire RAID. But let's have a look. We talked about the fast thing basically working there. This disk drive here that you can see that we've ringed with the yellow or orange light on, that orange light basically means there is a problem with that disk drive. Doesn't mean it's dead, it means there's a problem. This is essentially our fast system basically popping up and going, mate, this drive is about to fail, you probably want to swap it out. Now, if this was a RAID 5 disk drive, I could very happily pop that out because it's hot plug and play, put a new one in, push that in, and the RAID controller will rebuild that RAID array. So it will recopy data back onto that to establish the RAID again, and everything will be healthy. So if you get work in a data center, you will be wandering around, and every now and again you will see these lights on. And you'll be reporting those back, and you'll be swapping those in and out. It's really good fun actually doing it when it's live. It works nicely. Any questions about some RAID failures then? That's basically reported by fast. A lot of systems will have remote monitoring anyway, so they'll be taking off the fast reports and you'll be looking at it from a remote desk. And the remote desk will give you a little heads up saying this disk drive's having a wobble, possibly you want to go around and replace it. Okay, some other problems you can have extended read-write on some of the RAID drives. Okay, again, this is a similar stuff that we talked about for fast, so we may get a reduced IOPS, that's input-output operations per second. Again, some of this could be caused by a problem with the RAID controller or with the disk drives themselves. Can happen an awful lot when a disk drive is running out of space, or with the old spinny disks that you've got some high fragmentation. Or as I say, your disk could be falling apart, which means you've got a lot of bad sectors on the disk. Can also happen if you've got a lack of physical memory, essentially your RAM, because what happens when you reduce the amount of RAM, or your RAM is basically getting clogged up, is a lot more writes are done to the disk to compensate for that. So your disks are working a lot harder. Any questions about the extended read write? Oh, Kahoot. Everyone ready for a Kahoot quiz? Give you a couple of seconds just for any stragglers to get on there. Okay, fingers at the ready, everyone. The puzzle. Place these method steps in order. First step at the top, and then working down. I'm definitely not giving you the easiest four to put in order, but we should be able to do. I see three of you got in there already. And the others coming in rapidly. Well done for people. These are quite often the fun ones in Kahoot, where we kind of separate a few things. Wow, we got a lot wrong. And that's because I gave you the tricky ones. Okay. The first one in order that we should do is identifying the problem. Then we need to establish what theory it is. What's our hypothesis that we have there? Then we're going to test our hypothesis, and then we're going to establish a plan to resolve it. If you didn't get that wrong, is that clear to everyone? That's the order we put those ones. There are more on the list, but we only tested those four because those are the important ones. Good. Ready for the next question? Ah, Sebastian, Prince, and Peter's nailed that one. Well done. Smart is a technology to detect errors in what type of device? That's more like it. Disk drive. So smart basically deals with our disk drive errors. Well done, everyone who got that one right. Sebastian's cracking the lead. Prince, Peter. Let's see if we can close that gap. True or false? True. It does help us prevent data loss from bad sectors, because a bad sector essentially will mean a disk drive will fall over. If disk drive falls over, our RAID is there basically to help us out. Prince still at the lead. Peter up there. Cablan. Paul, well done. Let's see where we go from here. Place these in order are the number of disk drives that can fail on a RAID array. I remember this one. I may have put RAID 1 in there twice. So I doubt anyone will get this right unless they guess which one is RAID 5 in there. Let's see how it goes. See Paul typing. That's chastised me, Paul, for putting RAID 1 in twice. Not your night. Only one person guessed which one was RAID 5 in there. Well done. I might see if I can skip that question next time or rewrite it. I'll tell you, I'll rewrite it for next time, but well done, people. Okay, so that's the initial part of the Kahoot quiz. Any questions about RAID or troubleshooting disk drives? Good stuff. Okay, so we're going to move on to techniques for video projectors, and we kind of fly through this fairly quickly. Please put up a hand or something if I'm going too quick, or if you want to ask any questions. Excuse me. So display troubleshooting. Most of the problems we have with our displays are physical cable issues. Yes, it's not plugged in, either a power cable or the connection is wrong. But we can get things like fuzzy images, display burn, dead pixels, flashing, incorrect color displays. We're going to go through those in a little bit. So the loose connections are probably the biggest issue that we tend to have. Damaged cables can also cause problems. I've seen people ride their wheels of their chair over cables that causes problems. Bent and broken pins are really common in the old the old systems, but not so much in the HDMI because we don't have cables that don't have the pins that bend and get wrong in there. So one thing you need to check for fuzzy images are things such as your video resolution. Whether or not the resolution is correct will basically do things strange for it. You can also have a look at the refresh rate. Most systems run at a refresh rate of 60, but you can turn that up and down depending on what you've got. And normally the systems are clever enough now that there is communication between backwards and forward communication through the HDMI cables, where your system is able to recognize exactly what monitor you've got and therefore set the right video resolution and the right refresh rate. Video scaling can also cause problems because, of course, we are scaling in and out, and therefore it may not hit the pixels correctly. Most operating systems, you can adjust the scaling. Who's ever had experience with burn-in display images? Essentially a ghost image on the background or ghost image on the system. Thumbs up would do. Paul Bell, I can see you typing. Old Pixel phone, yeah, certainly. Chris has. Yeah, I can see a couple basically going on there. Yeah, I mean, definitely you can get it. Nowadays, with the modern monitors, it's less predominant. When we had the old CRT monitors, you know, those big chunky things that you have to have 8 people to carry in and out of the rooms. Yes, those ones were real problems for it because essentially you're hitting a screen with electrons, so you do get a lot of burn-ins. I've seen it on some other more modern displays. It's horrible, okay? But nowadays you have to really leave them on 24/7 for an awful long time before you'll get those sort of issues. Thank God for that. So now our systems are basically made up with individual pixels. Okay, so we can see those individual pixels. There's 3 pixels in each. You can see it clearly there that make up the color. And that's what gives us the different colors. These are green, blue, and red. Don't know why they didn't put it down the other way. They used to call RGB, red, green, blues. So when one or more of these pixels dies, because they can die, you will get a slightly different image. You can get whole loads image of failures on the systems as well. All monitor manufacturers will tell you you will not get it replaced until there's a certain percentage of pixels that have failed. Okay, so just because you've got a couple of dead pixels in the top right-hand side of your screen doesn't mean you can phone your manufacturer up and go, yeah, I want a new one. Because the first thing they'll do is they'll say, well, what sort of percentage is it? You don't have to tell them the percentage, but they will look at the percentage and go, that's still within acceptable limits. Marcus basically used to play a lot of Duke Nukem, and it says it's basically turned pink all of a sudden. Yes, you can have some problems with some of these things. So we can get flickering as well. When you have dead, as I said, when you have dead pixels, yes, it's a manufacturer issue that we need to get replaced. Flickering images. Okay, we potentially would need to look at the drivers on those. Is it the driver causing the problems? Adjust the video resolution. Check the cables. I'll say it so many times. Check cables. Cables and cables. That's what you need to check. We can get simple things such as the incorrect color display. Could be distorted. Some simple steps we can do if we think our color display is wrong. Yeah, turn it off and on again. While we know it's a classic IT solution. Restart the computer and try logging on as an alternative. If you're using a CRT, no, we'll ignore that one. No one ever uses a CRT, but they used to have a little degauss button on them that basically reset the two magnets that fire the electrons around. Okay, so we don't have those anymore, but in case you have ever run into one of those, you can, in your operating system, you can reset the display settings. Also, a lot of monitors have their own settings, don't they? So you can basically go into the menu of that particular monitor, reset it all. That might bring it back to what it should be. Move swiftly onto audio troubleshooting. So we know we all love beautiful sound. It's great when we're playing our fantastic music. We need to get our audio correct, isn't it? Most issues are caused by, strangely enough, cables again. I've said that several times, haven't I? Yes, so cables are the main cause of audio issues. Has anyone ever experienced that slight crackling when they're moving the cable in and out? Okay, that tends to be one of the big key things that you'll notice. Okay, and that's the first sign that you haven't either got a dodgy cable or your cable is not seated correctly. I know it's a horrible noise, isn't it, Marcos? So one of my main problems, and everyone has this every now and again, when they come onto video conference calls, is making sure that it's set to the right device. I've got several devices here. I've got a set of speakers that come on the laptop, don't you? So you have the laptop speakers. I've got LG monitors that have speakers in them. And not only that, I've got a set of other speakers, a larger set of speakers that I used to play lots of tunes on, that then plug into the LG monitor that basically takes the feed from HDMI. So if I haven't got one of them turned on, or I've got it to set to the wrong output, then I'm going to have noise issues. And of course, a lot of our stuff is now played through Bluetooth. So we can get audio issues with Bluetooth. So check it supports Bluetooth, use the audio playing troubleshooter as part of the operating system. That's all part of Windows, isn't it? Reset the default playback system to make sure you are sending it to the relevant Bluetooth device and not to your neighbor or not to your son who happens to be sat in his room with a set of headsets you've now just connected your Bluetooth to. He'll come in pretty quickly if he gets it wrong, isn't it? And again, we can look at our drivers to update the drivers, of course, and see if that causes or resolves any of these particular issues. Projectors are, I don't know, they're a fun device. They don't get used very often nowadays, but they are covered in the CompTIA, so we do cover them. It's important you understand essentially what they are. Projectors are based on a very light, very bright light source running through some essentially electronic screen that then projects out. So they overheat because a lot of the old bulbs, if you want essentially lots and lots of light, you produce lots and lots of heat. So do not put them in the middle of the room on a desk and then think, oh, I'm going to cover this up with some Christmas decorations so no one can see where the projector is coming from. The chances are you're going to block the fans, the thing's going to overheat, and rather than having a nice chilly Christmas day, you'll have some nice fire to cook your sausages on. So if cooling down resolves the issues, then it could be the heat that's basically causing the problem. Use an AC or external fan on hot days is one of the good ideas. Maintenance, check that it's dust free. Ensure the internal fan is working properly. Okay, and trigger the fail-safe mechanism. There is a fail-safe mechanism on these that automatically shut it down. One thing I would say about projectors, the ones that do produce an awful lot of heat, the very bright ones, fantastic. turn them off on the machine itself, not by pulling it out of the power socket. What they have is they have a fan that will overrun. So when you shut it down, the light goes off and then the fan will continue to run, much like your car will do on a hot day. So the fan will continue to run to blow cool air across the bulb, because if you do not do it that way, the heat will still build up on the bulb and you will still cause some problems. Any questions about display troubleshooting? Oh, let's drop into Kahoot then. Let's see what we can do. Ready, everyone? Fastest fingers. Here we go. Multi-select. Which of the following can cause a display flicker? Oh, good variety of answers across there. Well done. Normally, it's either going to be a backlight, which is on the screen itself, that causes the issue because it interferes with it, or an inverter problem. Let's see who got those ones right. Oh, Sebastian's shot up there. Paul B coming into it. Chris as well, a highest climber. Last question of this short section. If my audio is crackling, what should I do? Cables, cables, and cables. I'll say it again and again. Yes. Most of the stuff that we have in terms of this troubleshooting area for these particular sections are based around the cables. Let's see how that fixes it. Paul, back in the game. Well done, Paul. Okay, so just covering a few more pieces at the moment then. So let's have a little chat about troubleshooting processors and memory. Okay, we know we can suffer from things such as a high CPU usage, single core overuse, which is basically where one of the cores on your multi-core processor is being smashed to pieces because everything's running like that. CPU wait times, okay, due to slow disk or network subsystems. So if your disk is running slow, but your CPU is running fantastic, it basically causes a slowdown, doesn't it? And if your CPU goes above a particular temperature, according to the manufacturers and the systems that you're running, the system can shut itself down because it wants to protect the processor rather than burning it out. And then, of course, the nastiest one that's on there is the malware. Can consume a mass of your CPU. If your malware is running around trying to encrypt everything possible, yes, it's going to be burning your CPU time up. Well, we have tools that will help us with these things. So Windows, we have Performance Monitor and Task Manager. Because the Task Manager is used to monitor the CPU usage and we can see what's active, what systems are running. In Linux, we have Top and VMstat that will show us how our CPU is performing. And the Mac OS tends just to use Top, really, is the main one they use. These are all used to look at your performance for your CPU and it will find out how it is going. And from there, you can see if there is a problem or not. So this is what the Windows Performance Monitor looks like. As you can see there, the performance, it's not really getting thrashed at all, is it? So it monitors the CPU. It monitors other things as well. You can look at not just the CPU, you can look at other things that are going on in your system. So remember, Performance Monitor on Windows is where we go to basically check how our system is performing. On Linux, you can do it very much on the command line. Yes, there are other tools. I'd be surprised if anyone's running anything from the command line on Linux anymore nowadays. unless it's on the server system or basically maintenance of those things. But Linux does has a command line tool that basically will report how the system is running. And is that VM stat? Yes, VM stat there. And your Mac has top. Okay, so top will basically reel out a whole load of fantastic information that you can interpret. As you can see, some of it isn't that readable. But yes, this is what it does. It gives you as much information as possible on how things are performing. And from that, you can kind of work out what's going on and what's not working. Don't have to remember those in much detail. You just have to remember where you are going to look at those systems. Marcus, it looks like Matrix only in white. Yes, when you start dealing with stats, it is fantastic like that, isn't it? Okay, so that's simple CPUs. Let's have a little look at memory issues. Memory is probably one of the most common things you will ever change in a machine, be that a server, a laptop, or a desktop system. Okay, so make sure you're familiar with how to change it. It's very easy to alter. Memory issues, common ones up here are not enough available memory, so we need to upgrade it. If we get excessive disk read and write, that's from memory swapping because we do not have enough memory. So if your disk drive is really thrashing itself, remember if we went to our monitor, we could see our disk drive basically doing an awful lot of work. Could be that we've run out of memory. And indeed, our memory stats will show that we are using way too much memory. Your operating system can crash because a memory chip is faulty when it tries to overwrite to it. Or if we are overclocking the memory. Memory has a particular speed it can run at. Processor has a particular speed as well. If we overclock the system, then we get more and more errors because we're trying to do things a little bit quicker than potentially we should do. Any questions about common memory issues? I mean, I think generally with memory, what you look at is you look at a system. If a system is falling over constantly, because memory is the easiest thing to replace. If you think it's a hardware issue, sticking 2 new memory sims in the system is really quick to look at a hardware fix. If it isn't that, then you've got to look at something a bit more complicated. But a lot of times that will basically fix the issue, and you can look at which memory chip is faulty and then you can bin that. But we do have our tools basically that can give us a hand in these things, can't we? So we have tools again. MD schedule basically is a Windows memory diagnostics tool. There's Event Viewer and there are lots of third-party apps. Again, on Linux, there's a whole load of different tools up there, including our good old-fashioned tops, which is great for it. And the Mac OS, we have the Activity Monitor, PS Tops, and VM Stats. All these will get you details on how your memory is performing, how much memory you're using. It gives you hints and tips as to where you should be looking. Now, we're going to talk a lot about networks in the future, but part of the troubleshooting, we thought it'd be wrong if we didn't talk about some network troubleshooting. Okay, so these are some of the network troubleshooting tools that we will be using when we do some of the network troubleshooting. We won't use a lot of them. Okay, but there are Windows commands. Our Windows example command there is ipconfig. That will show us the Internet Protocol configuration of our system. Shows us our IP address. That's probably one of the most important ones, along with ping. Ping is designed to basically see if a IP address is reachable. So it will tell us if one is reachable. Let's have a look. Who hasn't used ping before? It's okay to own up and admit you haven't. Just going to see who hasn't used it and to see if I need to demonstrate it quickly. We will go through more in our networks. I haven't, Paul. Okay, all these commands that you're looking at are run from a command prompt. So I'm going to quickly just show you a couple because we're talking about it. These are used for diagnostics. So let's have a look. ipconfig. ipconfig shows me the IP address. So if you're trying to troubleshoot some network issues, then these are really helpful because what this tells me here is this tells me my IP address is that. And my subnet mask is here. And my default gateway is this one. So I can then check that. If I'm a network guy, I can then check that and work out if that's right. Now what ping basically does is ping basically lets us find a location if it is reachable. So let me ping google.com. Don't worry about the address it comes back from. And as you can see, I've now demonstrated that I'm connected to google.com because I get a reply from google.com in about 5 milliseconds. Is that useful for people that haven't run that command before? We will go through these in more details when we start talking about the network sessions, because we do network in basic and advanced, and we'll have a little play with those. But as you can see, the different operating systems all tend to use the same sort of commands in there. There's an ifconfig in the Linux, an ipconfig and an ifconfig in the Mac OS. Ping is a fairly general one, as is traceroute. Yeah, it's basically to see if I'm connected to that particular network. So that says I can reach Google. Hold on a second. If I type this right, I'm just reading my IP address again. 192.168.1. So if I try to ping something that isn't reachable, I get a destination not showing. So a destination host unreachable. Gabitsu, you've asked, can I please for Linux and Ubuntu? I'm not sure if there's a question in there. Oh, okay, you don't have Windows anymore. Okay, that's fine. If you're running Linux, yes, you can use ping at the command prompt or at the terminal, I think they call it. So at the terminal, you can type exactly the same as I did. Precious, have a good day at work. So Gabitsu, you can basically do the ping from your Linux terminal. Does that answer that for you? I hope it does. As I said, we do go through this in a lot more detail when we talk about the networking. But the real takeaway at the moment from this, from the troubleshooting things, is that the operating systems have lots of tools to help you troubleshoot issues. They're all there to help you, and you can basically do it. Oh, I can't see that. Are you pinging google.com? Yeah, Bitsy, can I take that offline and we can discuss that sort of after we finish this particular lecture? And in the meantime, let's have a little look at the final part of our Kahoot quiz. Thank you. Let's see who's going to take the sweet time today. Last question, 7 and 7, true or false? If I don't know the answer, I should make up something and get rid of the caller. False. Yes, if you don't know the answer, take as much detail as possible and we escalate it. Do not be shy about escalation. So it's coming to that time. Let's see who wins the Kahoot quiz this day. Who's on the podium today? Gabino, well done. Third place, pat on the back. Prince, I hope she didn't leave before she won. Okay, second anyway. Paul B, first place. Well done, everyone. Thank you for taking part in that. I can see Precious in there as well. Good work, everyone. Okay, so it kind of brings us to a conclusion. Okay, we've talked about troubleshooting. We talked about troubleshooting, haven't we? We've given you a methodology in terms of how you look at all troubleshooting. As I say, this applies to computers, it applies to tech, it applies to homework, it applies to everything you basically have problems with. Okay, we've spoken about smart arrays and how good they are for RAID and the types of flags that they will basically give you. We've looked at a little bit of troubleshooting for video devices, what goes wrong, how to fix them, as well as our projectors. There are some questions about projectors in CompTIA because they still use the things. And we talked about some common computer system issues, toys. So we've spoken about some memory that can give you problems and how we look at those, and the CPUs and the disk and network and the tools. So we kind of introduce you to some of those tools that are available on all those different operating systems. So that's kind of an introduction to the troubleshooting end of